Hey, this is Mr. Warden. This is a video talking about the theorems and some of the sample problems for 8.5, and then I'll do another one about the problems that have been assigned. So this is 3 application theorems involving proportions. So these are basically useful theorems that have been developed in order to use the proportions of similar triangles to prove a variety of things. So Theorem 57. If a line is parallel to one side of a triangle and intersects the other two sides, it divides them proportionally. So here we have BE is parallel to CD. And what that does is it divides AB and AC into proportions that are the same as the proportions of AE and ED. So AB will be to BC as AE is to ED. So AB is to BC as AE is to ED. And then I would encourage you to try proving these theorems. So here's some hints. In a proportion obtained by similar triangles, substitute the sum of AC and the sum for AD. Then use the means extremes products, algebraic simplifications, and means extremes ratio theorem. So I'll let you play around with that, but this theorem will be useful to you in this chapter and beyond. So Theorem 58, if 3 or more parallel lines intersect 2 transversals, they divide the transversals proportionally. So we got A, B, C, D, and EF are all parallel lines. And they're dividing AC or AE, or they're dividing BF. They're also dividing AE, if you like. So what happens then is AC is to CE as BD is to DF. In a way, this is an extension of this previous theorem. So eventually AE and BF would intersect to make a triangle. And so any number of segments of that triangle side would be formed into proportional sides as well. So we've lopped off the top of the triangle and we just got a lower part. So let's imagine we did one more line here, and that would produce proportions as well. The one that I've always found the trickiest to make sense of, but it's a really useful one, and I'm going to take a little time with it because of the trickiness, is Theorem 59, which is called the angle bisector theorem. And so here's what it says. If a ray bisects an angle of a triangle, it divides the opposite side. So this is bisecting, this is AC, it's bisecting BAD. It divides the opposite side into segments that are proportional with the other two sides. So since we've bisected BAD, we have created not only two angles that are the same, 1 and 2, we've also created BC and CD. And BC is going to be C to CD as AB is to AD. So BC is to CD as AB is to AD. We could also have said BC is to AB as CD is to AD. That would be a proportion that will work as well. So here's the way that's proposed to prove it in the book. So we've got our givens, and then we know that that angle 1 and angle 2 are going to be congruent because if a ray bisects an angle, it divides it into 2 parallel lines. And then we're going to draw ourselves a parallel line through B. It's going to be parallel to our angle bisector. So this is going to be parallel, and that's going to provide us a few things. We'll also extend DA out to intersect with it at some point E. And what that's going to ultimately do is going to create an isosceles triangle over here. But let's see how we know that. So we will know that BC is to CD because because we've divided a new triangle with a line that's parallel to a new base. Okay, so ED, imagine ED is the base for EBD. So now we divide, AC is now dividing that with a parallel line. And so EA is to AD as BC is to CD. So they've written it the other direction, but that's okay. And so now we can start saying some things about some angles, and we're going to set this proportion aside for a second. We're going to come back to it. So we know that 1 and 2 are congruent, but 2 and 4 are also going to be congruent because they're corresponding angles, because ED is now a transversal for parallel lines. Also, 1 and 3 will be congruent because of alternate interior angles. But since 1 and 2 are congruent with each other, 2 is congruent to 4 and 1 is congruent to 3, 3 and 4 are congruent, which means that EAB is an isosceles triangle, which means that in this proportion here with EA is to AD as BC is to CD, we can now actually substitute AB for EA. And so this proportion here, BC is to CD as EA is to AD, we swap out the EA and replace it with AB, and now we got BC is to CD as AB is to AD. And so we've got the division of this side into two segments that have the same proportional relationship as the two legs of the triangle coming from that vertex. And so that is that theorem. So let's look at some sample problems. Here we got BE and CD are parallel. So there we go. We've divided the triangle with a parallel cut that's parallel to its base. We want to find ED and CD. So let's look at what we've got. We know that AB is 4. Let's see, which is ED. This is ED. So 4 is to 2 is 7 is to, that's going to have to be 3.5. Because 4 is to 2, that's a 2-to-1 relationship. So 7 to ED will be a 2-to-1 relationship as well. And CD, 6, CD is the, so we're going to have to now deal with the large side to the small side. So from AC is 2 plus 4, so that's 6, and AB is 4. So there's going to be a 6 to 4 or 3 to 2 relationship for the big triangle to the small triangle. So CD is to 6 as 3 is to 2, or 6 is to 4. So CD needs to be 3/2 times 6, so CD will be 9. Okay, and let's see if I got that right. I think it'll have told us on the other side of this. Yes, in fact, X was 3.5. Okay, so, well, I should say ED was 3.5 and CD was 9. So we walked through the whole thing. We labeled EDX, we labeled CDY, and solved it that way. Now we've got this one. This is using the second theorem that showed up in this one, which is the multiple parallel lines cutting through, having two transversals to them. So we got A, B, C, and D are all parallel. We've been given some lengths that are shown, and we know KP is 24. Okay, so the way you deal with this, if we want to find Km, what we need to do is find Fj. So Fj is going to be, because we've got Kp, we can get Fg, and Km is corresponding to Fg. So we need Fg is to Fj as Km is to Kp, because Kp is something we know. So 5 is to 5 plus 2 plus 8, so 5 is to 15 as Km is to 24. Well, 5 is 1/3 of 15, so Km should be 1/3 of 24, so it should be 8, and it is. Now we've got an angle bisector theorem here problem, and we've been given that RVS is congruent to SVT. That means that RVT has been bisected by VS, and so RS is to X as 8 is to 10 based on this. So RS is to ST as RV is to VT. Or VR is, we could also say VR is to VT as RS is to ST. Okay, well, so that means 8 is to 10 as 4 is to, okay, well, 8 is to 10 is 4 is to 5. So X will be 5. And Let me move my face one more time and take a look at these sample problems. So here we've been given XA as is parallel to YZ, and XAY is congruent to XX. So XAY is congruent to XYA. So that tells us that XA, and that tells us that XAY is an isosceles triangle. That'll be useful to know. And we're trying to prove that WX is to XA as WA is to AZ. Well, this is just going to be a substitution thing because we do know that WX will be to XY as WA is to AZ. But since XA and XY will have to be the same because of these angles being the same and XAY being an isosceles triangle, we can substitute XA for XY. And instead of WX to XY is WA to AZ, we can say WX is to XA because XA and XY are interchangeable by substitution. And you can read through that and get more detail. Now we've got sample problem 5. We have DH is parallel to BC. We also have HF is parallel to BG. And we're trying to prove that CD is to DE as GF is to FE. So the nice thing is we've got these two triangles and they've both been divided by a line that is parallel to their base. And so we're probably going to end up with some transitive property stuff happening. So we've got the given of DH is parallel to BC. So that means that CD is to DE as BH is to HE. And then we've also got HF is parallel to BG. So BH is to HE as GF is to FE. Now, both of those proportions ended up being equal to BH is to HE. So we can actually just string a series of proportions. So CD is to DE as BH is to HE. Transiting over to here, as GF is to FE. So CD is to DE as GF is to FE by transitive property. All right, I hope that was helpful, and I will now stop and do a new video on the problems that you've got to do in this.